All right, and today we're going to cover sections 2.3 and 2.4. We're going to talk about absolute value. And on the last class, hey, I posted this video lecture, Algebra Common Graphs, and it dealt with the common graphs of algebra and the transformations and how those transformations on graphs play into the actual equation. In section 2.1 of XYZ, it deals with absolute value. 2.2 deals with the square root property, okay, and their transformation. So this video should take you to through the first couple of sections. In today's class, we're going to take a look at solving absolute value equations and solving absolute value inequalities. All right. So just to let you know where I'm pulling these documents from, I'm going to go into the lecture notes section, and I want to take a look at the section 2.4 set of notes. Okay. Now, if I actually go back, notice that there is an absolute value equations and inequalities video. Okay, so you may or may not want to watch that, but that's just some additional information on absolute value equations and inequalities. Okay, and on this slide in particular, okay, we actually did talk about the vertical and the horizontal shifts with the algebra's common graphs. And I'm going to go down a few slides and we're going to take a look at this slide. Right, and these are the formulas that we're going to use to solve absolute value equations and inequalities. Okay, and we have three cases. The very first case, case one, is to solve an absolute value equation, right? An equation is anything that contains an equal sign. Right, so it's not actually letting me highlight it, but this would be an absolute value equation. So it says if the absolute value of ax plus b, right, is equal to k, then we want to solve for ax plus b is equal to k, right? We drop the absolute value, right, and we solve it equal, we set it equal to k, or we drop the absolute values and we set it equal to negative k. And in this case, we will have two solutions. Next, we'll look at the compound inequality. This is the absolute value greater than or greater than equal to inequality. If you had an equal to bar, right, that equal to bar would just simply follow in the formula. However, if there is no equal to bar, okay, then no equal to bar follows in the formula. So this reads for case two, the absolute value of ax plus b is greater than k. Then you want to solve the compound inequality. Ax plus b is greater than k, or ax plus b is less than negative k. And then lastly, we have case three. This is the absolute value less than inequality. So it says to solve the absolute value of ax plus b is less than k. This is a three-part inequality. And we would rewrite our absolute value less than equation as negative k, right? So notice they take k and k is made negative. It's less than ax plus b, so the absolute value bars are dropped, is less than k. All right, so we take this absolute value less than equality and we set it up as a three-part inequality. All right, so let's take a look at some examples. All right, so this very first example we're going to take a look at, this is actually similar to like the first problem in section 2.3. And the directions are simply to solve. So we have the absolute value of y minus 6 is equal to 2. All right. So now those formulas that we saw earlier, okay, we can actually modify those, and I'll just kind of write them out to the side. And what I mean by modify is we can actually make them a lot simpler than they actually are. So the formula that I'm going to use here says that if the absolute value of A is equal to C, right? So instead of just writing AX plus K or whatever inside of the absolute value, I'm just simply going to shorten that down and write A. If the absolute value of A is equal to C, then we solve A is equal to C, or A is equal to negative C, right? And then just one thing about these formulas, just put that in a circle. I mean in a rectangle. And one thing about these formulas that may not be apparent on first sight is that before you use these equations, all right, or these formulas to solve, you must isolate for your absolute value. Okay, so isolating for your absolute value means that the absolute value is on the side of the equation by itself. All right, so we're going to use the formula to simply rewrite this. So I'm going to drop my absolute value bars. Okay, I'm going to write y minus 6 is equal to 2, or, and then I'm going to drop my absolute value bars again, y minus 6 is equal to negative 2. Okay, and we're just simply going to solve both equations. So if we take a look at the equation on the left-hand side, y minus 6 is equal to 2. I'm simply going to add 6 to both sides. Right, I'm going to bring down y. The 6's are going to cancel, and then 2 plus 6 is 8. So one of my solutions is 8. I'm also going to solve that second equation. So for the second equation, again, I'm going to add 6 to both sides. And we have y is equal to 4. So for the final solution, y is equal to 8 or 4. Okay, now there is no order in which you have to write these. Okay, these are just simply two numbers that make this equation true. Okay, and you can also check. So I'll go a step further and I'll check. However, you must only check one number at a time, and we must always check with the original equation. So the original equation is y minus 6 is equal to 2. And we're going to substitute y for 8. So we have the absolute value of 8 minus 6 is equal to 2. 8 minus 6 is 2, right? But that's still within the absolute value. And now if we drop our absolute value, 2 is equal to 2. So that checks out. We can also check 4. The absolute value of y minus 6 is equal to 2. We're going to substitute y for 4. So we have 4 minus, the absolute value of 4 minus 6 is equal to 2. 4 minus 6 is negative 2. Okay, and that's still within the absolute value. So if we apply the absolute value property, we have 2 is equal to 2, and that also checks out. Right now, the check is optional right on these, especially when we deal with the inequalities, because in the inequalities, there are more than, or maybe more than a couple answers that make that inequality true. All right, so let's take a look at another example. Add another example. Seven times the value, absolute value of x plus 5 is equal to 54. And again, the directions are just to solve. Okay. Now, as I mentioned earlier, before you even apply our absolute value equal to formula to solve this, we must first isolate for our absolute value, right? So we have to isolate it. So the first thing we're going to do here is I'm going to subtract 5 from both sides. Right? So I'm going to bring down 7 times the absolute value of x. That comes down. The 5s are going to cancel. I'm going to bring down equal to. And 54 minus 5 is 49. Right? So we want to solve for the absolute value of x and not 7 times the absolute value of x. So the next thing we're going to do is divide both sides by 7. So we have the absolute value of x is equal to 7, right? By simply dividing both sides by 7. So now we've isolated for the absolute value, and now is the only time we can apply the formula. So I'm going to drop my absolute value bars and set it equal to 7. I'm going to drop my absolute value bars and set it equal to -7. Okay, since both of these equations are solved, x is equal to 7 or -7. All right, so at this time, okay, I'm going to give you an equation to solve. So we have the absolute value of 3x plus 4 is equal to -2x plus 10. All right, so I'm going to give you a few minutes to solve this problem, and then we're going to return with the solution. All right, so let's take a look at it, at the example. Now, in this example, notice that the absolute value has been isolated. All right, there's no multiplier for the absolute value. There are no additional terms on the same side as the absolute value, so we do have isolation. So I'm going to remove my absolute value bars, right? So I'm going to write 3x plus 4 is equal to negative 2x plus 10. And you'll see why I'm putting this in the parentheses in just a second. All right. So this is the so we have if the absolute value of A equal to C, then A is equal to C, right? So that's this part. So you remove the absolute value bars and you set it equal to whatever it's equal to, or A is equal to negative C. So I'm going to drop the absolute value bars and I want to set it equal to a negative. All right. So notice here, this is understood positive, right? Just like this is understood positive. And then over here, we have negative. So now I just want to solve these two equations. So for the first set, I'm going to bring down 3x plus 4. And since there's an imaginary positive 1 on the outmost side of this parenthesis, if we distribute 1, that's going to simply remove our parentheses and give us negative 2x plus 10. All right, so now it's just a matter of solving it for x. So I'm going to add 2x to both sides. Right, so 3x plus 2x is 5x. And then on the right hand side, the 2x's are going to cancel. And then I'm going to put all my constants on the right hand side. So I'm going to subtract 4. So on the left hand side, my 4's are going to cancel. And 10 minus 4 is 6. Right, so I have 5x is equal to 6. I'm going to divide both sides by 5. So x is equal to 6/5. And now in order to solve the other equation, we have 3x plus 4 is equal to, and here again, I want to remove the parentheses, so I'm going to distribute. So remember our rules of sign. A negative times a negative is a positive, so that's a positive 2x. A negative times a positive is a negative, so that's minus 10. All right, so now we're going to do the same thing. We're going to solve it for x. Right, so I'm going to subtract 2x from both sides. I'm going to bring down my equal, and the 2x's cancel. I'm going to subtract 4 from both sides. Right, so the 4's are going to cancel on the left-hand side. Negative 10 minus 4 is negative 14. So x is equal to 6/5 or negative 14. All right, and that's how we solve absolute value equations. Okay. Next, we're going to take a look at absolute value inequalities. right? So if I go back to case number 2 and case number 3, right? We'll notice that for case number 2, and give me 1 second. I'll do, okay, and if we look at case number 2, we have the absolute value greater than. So it says the absolute value of ax plus b is greater than k. Then we have to solve the compound inequality. Ax plus b, we remove the absolute value bars, right? And we keep it as it is. Where's my mouse here? So remove the absolute value bars, we keep the greater than inequality, or ax plus b is less than negative k. So we change the sign and we reverse the inequality. Right? And then for our last one, we have the absolute value of ax plus b is less than k. Right? And we change the sign on our value for k. We drop the app and we bring down, and we bring down the less than inequality. We remove the absolute value bars. We bring down another less than inequality, right? And we keep our k value with its same sign. All right, so there is some maneuvering on these formulas. All right, so let's just see how they work. Okay, now this actually comes from section 2.4. So I want to bring up some problems from 2.4. Okay, and first there's look like there are some graph problems. So okay, sorry about that. I got kicked offline. Okay, it looks like I'm still recording. Okay. Okay, give me 1 second, and I have to bring up all the windows again. Okay, here we are. Okay, so now we'll take a look at those formulas, and I'm just going to write them in a simplified manner. So this is the absolute less than inequality. So it says that if, and you may have seen them written this way in your intermediate algebra course, if the absolute value of A is less than C, then negative C is less than A is less than positive C. And again, the formulas are the same, but these are just in a less convoluted format. Now we'll take a look at the absolute greater than inequality. And it says that if the absolute value of A is greater than C, then A is greater than C, and at the same time, A is less than negative C. All right. And again, if we were to, let's say, if we look at the first one, it says if the absolute value of A is less than C, if we had an equal to bar, right, the same formula applies. The only difference is the equal to bar will also appear in the formula. And the same is true for the greater than or greater than equal to. So it all depends upon what you're given to. If you're given a greater than inequality, right, you would simply keep it as greater than and less than. But if you're given a greater than or equal to, then that will travel in the formula. All right. All right, so let's take a look at an example. In this example, we're asked to graph the solution to the absolute value of x is less than or equal to 4. All right, so here again, what's implied is that when using these formulas, you must isolate for your absolute value. So in this case, the absolute value is isolated. We have the absolute value of x is equal to 4. In order to graph it, I'm going to use the greater than or greater than, the less than or the less than equal to formula, which is this first one, right? So I'm actually going to apply that to the absolute value of x is less than or equal to 4, right? So what the formula says is that it tells us to, and I actually just want to write this out. So if the absolute value of x is less than c, negative C is less than A is less than positive C. Okay, and I'm just simply going to jot that above my formula. So in our example, we have the absolute value of X is less than or equal to 4, right? So since we have a less than equal to, I'm simply going to attach the equal to in the formula, right? And then I'm going to apply the formula. So it says then I have negative C. So notice that C represents 4. So I'm going to change 4 to a negative 4. I'm going to bring down the less than or equal to inequality. Whatever I have within my absolute value bars, the absolute value bars are dropped. I'm going to bring down the less than or equal to, and since C is equal to 4, I have 4. So this is now negative 4 is less than or equal to X is less than or equal to 4. And we simply want to graph it. Right? So that's 0, 1, 2, 3, 4, 5. Okay, negative 1, negative 2, negative 5. I'm going to just draw my arrowheads to allude to the fact that this graph keeps on going. And we talked about graphing compound inequalities in the previous section. So since we are basically interval notation, but when we graph these, we're using open circles and closed circles, right? So remember that the first part of this, negative 4 is less than or equal to X. That can actually be written as X is greater than or equal to negative 4. Right? When our variable is on the left of the inequality, we can use which way that inequality is pointing to tell which way that if we were using interval notation, which way our symbol should face and which way our line should go. But here, since I'm using open and closed circles, since I have the equal to bar at negative 4, I'm going to draw a closed circle. We want all values that are greater than or equal to negative 4. So my line is going to move toward the right. So it's a closed circle at negative 4, and the line is going to move to the right. And at the same time, X is less than or equal to positive 4. So I'm going to draw a closed circle at positive 4. I want all values less than or equal to 4. So my line is going to extend to the left. And this is our graph. All right. All right. So now I'm going to give you one to attempt. So in this example, we're asked to graph the solution. The absolute value of 6x minus 18 is greater than 24. All right. So I'm going to start off just by giving the formula. So it says if and I'm going to modify it a little bit since we're graphing. If the absolute value of A is greater than C, then solve A is less than negative C and A is greater than positive C. All right. So I'll give you a few minutes to attempt this problem, and then we'll be back with the solution. All right, so we're going to take a look at the solution. So we have the absolute value of 6x minus 18 is greater than 24. All right, so just keep in mind that C is equal to 24 and A is everything that's within the absolute value. All right, so now we're going to remove the absolute value. So we have 6x minus 18. We're going to reverse the inequality. We're going to make C negative. So we're going to make 24 negative. And for the second half, we're going to remove the absolute values. 6x minus 18. We're going to keep our inequality as greater than, and we're going to keep our value for C, which is 24. We're going to keep it positive as it is. Right, so now we're going to solve these two inequalities. All right, so the first thing I'm going to do is I'm going to add 18 to both sides. So we have 6x is less than -6, right? Because if I add 18 to both sides, the 18s cancel on the left, and -24 plus 18 is -6. And then I'm going to divide both sides by +6, so x is less than -1. Okay, now we're going to solve the second half. So again, we're going to add 18 to both sides. So 6x is greater than 42, right? 24 plus 18 is 42. I'm going to divide both sides by 6. So x is greater than 7. And this is what we're going to graph. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. -3, -4, -5. Okay, we'll extend that. All right, so we're going to graph x is less than -1. So at 1, I'm going to have an open circle, right, because I have no equal to bar. I want all values less than -1, so that line is going to extend to the left. And at the same time, x is greater than 7. So there is an open circle at 7. I want all numbers greater than 7, so that line extends toward the right. And this is our graph. So now if we were to write the actual solution out in interval notation, okay, this is what the solution would look like. Okay, now even though it asks to graph, there are problems that ask for the interval notation solution. Right, so I'm just going to extend this out a little bit to -infinity to the leftmost, +infinity to the rightmost. So if we take a look at and you want to make sure that when you write out your interval notation, it has to follow a number line from left to right. So we would write this as a parenthesis, -infinity, right? Because we must always encase infinity with the parenthesis, comma, -1 with the parenthesis, right? Because we have an open circle at -1. Union, right, which is or. Our solutions can lie on the interval from 7 to infinity. Now, if you were to write this interval notation in any other way, it would be incorrect. Your interval notation must follow a number line from left to right. Okay. So now the first couple of examples, they just ask to graph. The other problems in this section, they actually want you to solve them and express your final answer in interval notation. So let's take a look at a few of those. All right, this looks like a good one. All right, so here we're asked to solve and enter the answer in interval notation. Using U, that's that union symbol, to indicate a union of sets. Now you're only going to use that union symbol if you're dealing with a greater than inequality or greater than equal to. All right, so here is the problem. We have 3 times the absolute value of 7a plus 6 plus 9 is less than or equal to 18. All right, so I'm gonna pause the video and I'm gonna give you a minute to solve it, and then we're gonna return with the solution. All right, so let's take a look at the solution. Now, before we begin to use the absolute value less than equal to formula, we must first isolate for the absolute value. So the first thing we're going to do in this example to isolate for the absolute value, I'm going to subtract 9 from both sides. All right, so if I subtract 9 from both sides, I have 3 times the absolute value of 7a plus 6 is less than or equal to 9. Okay. I want the absolute value and not 3 times the absolute value, so I'm going to divide both sides by 3. So now we have the absolute value of 7a plus 6 is less than or equal to 3. All right, so now our absolute value is isolated. So just notice the process. When you isolate for your absolute value, you want to add or subtract any terms that are on the same side as the absolute value first. Then you want to divide by the quantity, if one, on the outside of your absolute value. Okay, so in this case, we had a multiplier of 3, right? That 3 was multiplied by the absolute value. So we use the opposite operation and we divided both sides by 3. Okay. So now we can use the formula. So I'm going to write this out as -3. And since I have the equal to bar, is less than or equal to 7a plus 6. So I remove the absolute bars. And that is less than or equal to +3. All right, so again, we are using this formula. Okay. So now we have what's called a compound inequality, and we're basically going to solve it from the inside out. And we want to let A, right? We want to isolate for A inside of the inequalities. So the first thing I'm going to do here is I'm going to subtract 6 from all 3 sides, right? Because I'm dealing with 3 sides instead of 2 sides. So I'm going to subtract 6 from the leftmost, from the middle, and from the rightmost. Right, so -3 minus 6 is -9. I'm going to bring down my inequality. The 6's are going to cancel, so we're left with 7a. I'm going to bring down my inequality, and 3 minus 6 is -3. Right, so our goal here is to isolate the variable in the middle. Right, so I want to isolate for a, not for 7a, so I'm going to divide everything by 7, right, all 3 sides. So we have -9/7 is less than or equal to a is less than or equal to -3/7. All right, and we want to write this as an interval in interval notation. So keep in mind that this is actually telling us 2 things. A is greater than or equal to -9/7, right? And at the same time, A is less than or equal to -3/7. So our interval notation solution is -9/7, comma, -3/7 with a bracket. All right, so notice I did not use that union symbol. The union symbol is only used for greater than and greater than equal to inequalities. All right, and now we'll take a look at one more example. Okay, and the directions are the same. We want to write in interval notation. So we have 3 times the absolute value of 5c minus 7 plus 3 is greater than or equal to 30. All right, so for this, to solve this one, you want to use that greater than or greater than equal to formula, which is, where is it? Which is this one. Okay. All right, and I would actually write it out this way with the less than and negative c, because when you actually solve it and graph it and write it in interval notation, that graph smoothly follow with interval notation. All right, so I'm going to give you a few moments to solve this problem, and we're going to return with the solution. All right, let's take a look at this solution. So, all right, here again, before we can use any formula for the absolute value, we must first isolate for it. So the first thing we're going to do here is subtract 3 from all 3 sides. Well, excuse me, subtract 3 from both sides. So I'm going to bring down 3 times the inequality of 5c minus 7. So we're going to subtract 3 from the right-hand side. So 3 cancels. We're going to bring down the greater than equal to bar, and 30 minus 3 is 27. Okay. Next thing we're going to do is divide both sides by 3. So we have 5c minus 7 is greater than or equal to 9, right? So we have isolated for the absolute value. Now we're going to apply the formula. So here we have, I'm going to drop the absolute value, 5c minus 7. I'm going to reverse the inequality, right? Is less than or equal to, and I'm going to change the sign for 9. Or 5c minus 7, right? I'm going to draw my absolute value bars. I'm going to keep my inequality, and I'm going to keep my sign for 9 the same. All right, and now we're going to solve. So we take a look at that first equation. I'm going to add 7 to both sides. So I have 5c is less than or equal to negative 2. I'm going to divide both sides by 5. So c is less than or equal to negative 2/5. Okay, I'm going to do the same process for the next equation. I'm going to add 7. So I have 5c is greater than or equal to 16. I'm going to divide by 5. So c is greater than 16/5. Okay. So when we write out our interval notation, and keep in mind that we had the greater than equal to, so we will be using a union symbol. Okay, so I'm going to write this out as the half open interval from negative infinity to negative 2/5. Right, and negative 2/5 has a bracket because of the equal to bar. Union, right, which is or 16/5 to positive infinity. Okay. All right, so notice that this follows a number line from left to right.